Hi, this is the explication of the simplification of the math term of the problem 2, part A. So here we have the three math terms that are these ones, and here are represented in this form. And so we began simplifying this using the theorem 6 part B that say that if we have a part A and a part A that is negated, that are with a plus with a part B, that the part B here is B negated plus A negated, you can get out the A. So we get this, that it's the part B only, that will be B negated plus A negated. And here, with these two, we can use the theorem 7 part B, that said if we have a part B and a part B negated, and a part A that it's equal on the two sides, and an extra part in the other equation that will be the part C, we can get the simplification like using the part A, that will be the A negated, plus my part B negated, that are multiplying the part A, that it will be A negated, plus the part C, that it will be C normal. And here this is the most that we can simplify this function in the math term part. And if we check this one with this one, we will see that we get the same exact results of the math terms.
In the theory tree, we need to find the simplest switching expressions. In this case, we need to do the problem number 2. I will explain the sum of products of this term, simplifying the 5 midterms that we have in this problem. First, we need to put all the midterms in the paper and start simplifying with the terms that we know. The first theorem that we know is and that we will use is the theorem 6a to start simplifying our problem. Then we will do the theorem 7a, and the last theorem that we will apply is again the theorem 6. These are the three simplifications that we do as a team, and the SOP that we have, or the sum of products, the final result are this one.
Welcome to the Logic Lab activity. We're going to simulate the second exercise in the SOP mode. Well, this is a mess. This is very difficult to understand well, but we're going to check it. First, we have the 0, 0, 0, that the motor is moving, as you can see. Then we're going to the 0, 0, 1, and it should stop immediately. And then we're going to the 0, 1, 0. This will turn on the motor. Then the 0, 1, 1, this will keep the motor on. Oh, sorry, it will turn off the motor, as you can see in the truth table. Then we go to the 0, 1, 0, 0, and this will keep the motor moving. Then the 0, 1, 0, 1 is the same. Then the 1, 0, 1, 1, 0, it will turn on the motor, and then finally the 1, 1, 1 that will kill the motor, as you can see here. Then the next procedure is to make the Boolean algebra and make another. With this new formula, we can see that it's very easy to understand, because we reduced all the big formula to a much more smaller formula that will help us to understand how this works. So I'm just building the circuit, as you can see. so I can activate as I want the model. It's very easy to do because the Boolean algebra helped me to make a shortcut, or I don't know how to say, help me to make a much more easier to understand formula. Now this one is a POS formula, product of sums formula. Is smaller than the last one that we saw. The last one I mean for the original one that we already saw, the SOP formula. But is still very difficult. I'm checking it with the truth table, as you can see. It's not very difficult. It's smaller, but easier to understand, but we still can reduce this function to a easier function or a smaller function. We can reduce all the logic ports that we are using right now. As you can see, all the truth table is okay, so we can move on to the synthesized formula, that is this one. And now we can keep going and build the formula. Is easier than the last one, than the original one, but it's a little bit bigger than the last synthesized formula that we saw, that was the SOP. This is a POS synthesized formula, and well, it's not very difficult, but it's a little more, it's longer than the last one. As we can see, I'm putting the logic parts. And well, thank you for watching, and goodbye and good night if you want.